Now, let's look at our second example. In this second example, we are going to introduce a concept from probability. And so let's look at this problem over here. We have a function f of xy, z, this function over here, is a constant times x, y, z, okay, which is defined in a cube. X is between 1 and 0, y is between 1 and 0, and z is between 1 and 0, okay? And so this is a function. You can see this is the area it's defined. And we want to determine the value of c so that the triple integral over the unit cube is 1. So the first problem over here is that we want to A over here, the solution. We have a triple integral over this cube. Let's say call this cube Q. How is that? Yeah, this cube over here. This is cube. Okay. And then we integrate this function called cxyz. And we have dx, dy, dz. Okay. And then what do? We say we want this integral to be 1. And this is, when this integral is 1, if you notice this function f of x, y, z is bigger than or equal to 0 when c is bigger than 0. So we want to have a function which is non-negative, and its integral is 1. This kind of function is called a density function. So c is a constant, so we can pull the constant c out, that's for sure. And then we have q over here. We have x, y, z over here. And then dx, dy, dz. So this is really about how to integrate, but we have a cube. What can be simpler than a cube? So we have just x is between 0 and 1, and y is between 0 and 1, and z is between 0 and 1. And because they're all constants, so we can integrate it with respect to any variable first. Okay, dx, dy, dz. So we can say, well, this is going to be c. Integrate with respect to z first, and that's going to be from 0 to 1. X, y, they're constants. I can take them out, and z over here, dz. And after we finish, we can say we're going to integrate with respect to dx, y, right? So when integrated with respect to z, of course, we're going to have 1/2 z squared, right? So we have x times y, and 1/2 z squared, and plug in 1 and 0. And then we still have dx, dy over here. So when we plug in 1, we get a 1/2. So we have c over 2, and 0, 0, 1, 1, and x, y, and dx, dy, right? And if we keep doing that, we will see this is exactly the volume of the, well, it's not exactly volume because we have x, y, z over here. If it were 1, then we can have just 0, the volume, right? So now from here, then we have, again, c over 4 now, and then we can have from 0 to 1. I'm skipping one step. Integrate y between 0 and 1, get a 1/2. And then we have x dx. And so one more time, we're going to have c over 8. If we want this one to be 1, then c has to be 8. Okay, so we solved the first problem over here. C is equal to 8. Okay. Now, we're going to do part B. This is going to be a triple integral, the same integrand, but the region has changed. If we look at the region more carefully, this is exactly the region that we did in the past. X is bigger than or equal to 0, y is bigger than or equal to 0, and x plus y plus z is less than or equal to 1. So for part B, we have the same region as we did in the past. V over here is the following. Okay. X is bigger than or equal to 0, y is bigger than or equal to 0, and x plus y plus z is less than or equal to 0. even though it's described in different way, but this is what we have. So this is going to be xy inside D. What kind of D it is? D is xy, and x bigger than or equal to 0, y bigger than or equal to 0, and x plus y is less than or equal to 1. This is the same D. And for each fixed D, fixed x, y, and z is going to be between 1 minus x minus y and bigger than or equal to 0. So we have this triple integral over v over here, and then we have the integrand is 8xyz and dv. Okay, sometimes we use dx, dy, dz. Sometimes for simplicity we just use dv. That's the same thing. So then we integrate. It's going to be over d again, and then 8 is a constant, so we can take out. In fact, we can say 8xy, they're constants, and take it out. And then z, we go from 0 to 1 minus x minus y, and then we have z over here, dz. And after we finish, we should integrate with respect to dx, dy. So this is what we have. Okay. All right, so now let's compute again. Integral z over here, dz, that's easy. That's going to be 1/2 z squared plus c, right? So we are going to have the integral over here, d, and then we have 8xy, that's a constant, and 1/2 z squared, plug in 1 minus x minus y and 0, okay? And then we have dx, dy. So plug it in, we're going to have 4 integral over d, and we have xy. Oh, now we are in trouble. 1 minus x minus y squared dx, dy. You may say why I was saying that we are in trouble, because we cannot find an easy antiderivative like the way we did in the past. Let's try more carefully. All right, so now what we're going to look at d over here, right? D is x between 0 and 1, and y is between 1 minus x and 0, right? We always actually draw 2 diagrams, one for xy's domain and one for the for v. So diagram number 1, diagram number 2. Okay, so this is 1. So we can integrate with respect to y first. X is between 0 and 1, and then x is out, and y over here is between 0 and 1 minus x, right? And we have y, 1 minus x minus y squared, and dy and dx. What a relief. It's not too bad. Why it's not too bad? Because if you look at what we have y, 1 minus x minus y squared. This y saves life, because we know we can now use the substitution rule, right? So we are really seeing this one over here. What can we do? Let's do this. We're going to call 1 minus x minus y to be t. Okay? If we do that, then what do we have? And then we're going to have, we look at y, so y is going to be equal to 1 minus x minus t, right? That's the same thing. So then dy is going to be negative dt, right? Yeah. So this one over here becomes 1 minus x minus t, okay? And then this one over here is going to be t squared, right? And this is going to be negative dt, okay? This is integration by substitution. So now from over here, then we have 1 minus x t squared and minus t cubed and dt. Okay, so just to be very patient, we don't have all simple integrals all the time. So this is going to be 1/3 1 minus x t cubed and minus 1/4 t to the 4th. Okay. I hope everything is going well. I'm not seeing any errors over here. Yeah, everything is fine. So, and when we put it back, then what we have? So we will have 1/3 y minus x. T is y minus x minus y cubed, and minus 1/4. T is y minus x minus y cubed to the 4th. Okay, so that's what we have. And unfortunately, so we will have over here 4 and 0 and 1 and x. Okay, so let's try to see what we have. If we plug in y minus x, then everything is going to be 0. So the only value that we have is negative when we plug in 0. So when we plug in 0, this is what we have. So when we have plug in 0, we have over here y 0. So we have, remember the negative sign. And then we have 1/3 y minus x to the 4th. And over here, y minus 4th and y minus x to the 4th. So it's not too bad. We have 1/3 minus 1/4 is going to be 1/12. So it's negative 1/12 y minus x to the 4th. So that's what we have. So we put it over here. That's going to be negative 1/12. And we have y minus x to the 4th dx. Okay. All right. So we get to use the integration skills actually we used in the past. So now what is this? This is going to be negative 1/3, and from 0 to 1. I have a feeling we lost a negative sign somewhere. Yeah, unfortunately we have to go back. But let me try to fix it over here. So let me try to fix it over here. So this negative sign we forgot. You may say how I got to know there is a negative sign lost, because this negative sign doesn't make any sense. You cannot have a negative integral over here. Everything is positive. So when I multiply this one through, I have t squared and then I have negative. So I lost a negative sign over here. So really I have positive. Okay, I have negative sign, and everything over here should be a negative sign. And then this is positive. Then I don't have a negative sign over here. Okay, and then so we need to be very vigilant. When we see something wrong, we should go back and check. And then we have x, 1 minus x to the 4th, and dx. Okay, and we play the same trick, because you don't want to multiply this out. It's going to be 5 terms. If we have a way, we don't do that. Okay, now how do we do this? We again do the same thing. Let's try. Integral x, 1 minus x to the 4th dx, right? We let t to be 1 minus x, and dt is going to be negative dx. And x is going to be 1 minus t. So when we integrate this one, we have 1 minus t, and t to the 4th, and negative dt. This time we can remember this negative sign. And you can see by doing this, we're going to have t to the 4th minus t to the 5th and dt. So integrate, then we have negative 1/5 t to the 5th and minus 1/6 t to the 6th, right? And then if we put it back, this is going to be negative 1/5 y minus x to the 5th and minus 1/6 y minus x to the 6th, right? But remember, we are evaluating a definite integral, so we actually put in 1 and 0. So let's just say put 1, 0 inside, and what do we have? If we plug in 1, we got 0. If we plug in 0, we're going to have 1/5 minus 1/6, and that will give us 1/30. So actually, this is what we have. We have 1 over 3. And this one over here, we have integrated out. That's going to be 1 over 30th. And we have 1 over 90th. That's the answer we have over here. Okay. All right. That's it. Sometimes we have to go back and verify everything's true. And it seems it's fine. All right. So let's stop over here.